Welcome to the Be Careful What You Ask For podcast with Jeff and Drew. I'm Jeff Wilson. I'm here with Drew Nelson, and we're from Ribbon Communications. Um, I am the sales guy on the call. I'm traditionally from a background of sales engineering and architecture. I've worked with customers for over 20 years, designing and implementing their optical and IP networks. And so that makes me the sales guy. And with me is Drew Nelson.
I am, in fact, that Drew Nelson. My background is very recently in sales engineering and architecture, but most of my career is spent operating networks and building them and watching them break and figuring out fun and creative ways to make them not break again.
So that makes you the operational guy, the guy who actually knows how this stuff works.
Exactly.
And, where I just like draw it on paper and then we set it up and leave it, you're the guy who has to live with it after we leave it. So,
or at least I was.
Yeah, you were. Exactly. Now you've come to the dark side. But
Right.
This is the Be Careful What You Ask For podcast, where we talk about current topics in network architecture and network technology. And Drew, you want to talk a little bit about where we came up with that name from?
Well, it's a funny story. We were having dinner with the sales executive and bantering back and forth about some subject or another. I couldn't remember the specific one, but after about 5 minutes of us discussing something in a relatively friendly way, she was like, "You guys should start a podcast." And, as with most sales executives, their wish is our command. And here we are.
Exactly. But we thought to ourselves, you better be careful what you ask for. But as well, it's about with all this new technology and new things, new ways to do things in networking, it's an attempt to help our customers and potential customers think about what they're really trying to do and to really be careful about what they ask for, because sometimes, they hear about this new thing and they decide that they've got to have that in their network, or they want to keep something that's been there forever because they think it works. And, we need to discuss how those things impact their network going forward. And so
Absolutely.
really what we're looking at is, talking about the new technology of the day, things that we've heard from our customers, and getting some perspective around that, and trying to work in a Ribbon commercial here and there.
A little bit, and maybe even entertain you. I'm told we get paid by the acronym.
Oh, all right. Well, we need to roll some out then right away. So let's start with
TDM migration.
TDM migration, exactly. Can you tell us a little bit about what it is?
Sure. So back in the dark ages, when the phone switches were chiseled out of granite and made out of, all the documentation was written in Sanskrit, we used to use these things called TDM circuits, or time division multiplexing. Everything from the lowly DDS 56K circuit all the way up to the massive OC 192 optical circuit. So a lot of these circuits still exist today and are still in use today, whether it be with a large carrier or with government entities or a small business that just whatever the equipment that they still have still requires that old T1 interface to get into it. Now, unfortunately, as time's moved on, a lot of the equipment that supports that has gone manufacturer discontinued, or manufacturer has passed away and gone into the annals of history. So that unfortunately leads to using a sparing strategy off of things like eBay or the gray market, which is not the most reliable, and in some cases, not the best way to support your network. But when it's what you've got, it's what you got to do.
And it tends to be a really expensive way, right? A
Sure
lot of times you have to buy 2 to 3 times what you think you need, because that gear that's none of it's new gear. It's all used gear. It's all come out of somebody's network somewhere. And, it may have been working when it was in that network, but as soon as it got unplugged, it died. And you don't know it until you plug it back in.
Right. Very few new digital cross connects being sold today.
Yes.
So TDM to IP, what we're doing there is we're offering circuit emulation services. So that's where we use an IP transport network to provide the bridge between TDM interfaces. Again, whether that be that lowly DDS circuit all the way up to, an OC48. And, we can even do a lot of the magic that happens inside digital cross connects today with those circuit emulation type services. So at its core, Jeff, what a circuit emulation circuit does is it takes the raw data that's coming out of your either your DS1 or your Sonnet type circuit, and it packetizes it, right? It makes it look like RTP would look like in a voice over IP telephone call, and it sends that across your packet network. So you can use whatever transport gear that you're using for your transport network, your IP transport network. MPLS is typically what gets used there, and allows you to build your TDM circuits across it. You essentially have a piece of hardware on either side that gives you that physical interface back to T1 or DS3.
But then you get to use it on the network you're running today and basically converge it in.
Exactly.
So you're not running a separate network just to carry these circuits. And I think we find that yes, there are still a lot of these circuits out there, but not nearly the scale that there used to be. And so, there's still a lot of this old Sonic gear, this old TDM gear that's out there that's running it certainly certainly less than full.
Absolutely.
And being that gear is old, it's very power hungry, it's very space hungry. It's got a lot of OpEx associated with it to have to overcome with the limited revenue that comes from those circuits. I know that a lot of our carriers think of those as really valuable because they don't have to do anything with them. They just sit there and run. But a lot of the times, they're very expensive from an OpEx standpoint, even if they don't realize it.
Yeah, win is free, not free, right?
Yeah.
Yeah, and if you look at it, your statements are 100% correct. We have several customers I've talked to that have, an OC48 interconnect back with a large carrier, and on that OC48 they have maybe two STS1s that have payloads in them, and neither of them are full. But it's not in anybody's best interest to try and shrink that OC48 down to something smaller, because that means they'd have to go find equipment to do it. So why do that? So again, what's kind of cool about these interfaces is, if you're bringing those in with VT 1.5 constituent circuits on there, you can actually map straight across. So in that example, say you've got an STS1 inside of an OC48, we can plug that into a circuit emulation device, and we can actually peel the individual VT 1.5s out of those STS1s and send them off to an individual DS1 card somewhere else in the network. And one thing we'll let you know about this podcast: if you don't like acronyms, you don't want to listen to this podcast, because we have them all.
Absolutely. Yeah, and I think one of the things that we run into with carriers is they're not selling a lot of these circuits new, right? They're maintaining circuits that are out there. So a lot of the times doing changes to their network, bringing in new gear, that doesn't excite them because it's not creating new revenue. I think 2 points about this are: number one, if you have the right gear in the rest of your network, you're not really adding a lot of gear, right? There's not a huge capital expense to get to TDM over IP, and it helps you run in a converged way. So your network is much more efficient. And the second piece there is the OpEx savings that you get from turning down that old gear. Really, it has the same effect on the bottom line as adding new revenue. So it's a plus.
Absolutely. I have certain customers we've talked to in the past where it even frees up a pair of fibers, right? So especially if they've got leased fibers in their network, they're still running this Sonnet network across there. They're able to tear it down. They get those fibers back, and they can either use that as the ability to turn up their new next generation DWDM, or to have, heaven forbid, spares.
Yeah. Well, and as well on the spare piece, yes, they can have spares for another part of their network. They also might have a revenue stream from that. Either, and I'm not encouraging this, selling into eBay, selling into the gray market, but as well, there are a lot of important metals in in those components that they can sell out into that metal reclamation market. They can make
Sure.
money off that copper and lead and those kinds of things, where they can actually turn that into cash that might help pay for that initial capex outlay.
And there are gray market resellers, right? Just not everybody's going to be in the
Sure.
same place for their TDM to IP journey where they're able to move to an IP, circuit
No,
emulation
true.
IP schema. So yeah, one man's trash is another man's treasure.
So when we talk to customers, what are the general approaches that you hear about this? The way they want to do things. One that I hear a lot is they want a new Sonnet box. They want to replace their existing Sonnet box, their ADM, their DAX, whatever. What are your thoughts on that approach?
So everybody wants to hit the easy button, right? And that certainly is just get a box that does the same thing that my last one did. But as we discussed before, nobody's making these boxes new anymore. So you kind of have to wrap your head around a change in philosophy here. Just about everybody out there has a transport network, like an IP transport network that they're using to carry either their broadband backhaul or backhaul for cell towers, things of that nature. And for the most part, they're running IP MPLS on top of it. So this is just another service that you can build to ride on top of that. Whether it's using our wonderful ribbon gear or not, we can be added in, right? Just
It absolutely should be using our wonderful ribbon gear.
Absolutely. But we can add on top of that and just build an MPLS tunnel that goes from A to Z and let the TDM transport ride over that MPLS TP tunnel. It gives you resiliency. There's communication within those TDM tunnel or those MPLS IP tunnels so that you get that similar 50 millisecond failover just like you would in Sonnet.
Yeah, so we talked a little bit before about mapping like the VT 1.5s. How do we do that through IP MPLS?
So each one of those VT 1.5s, the constituent circuits that you're going to have, those actually are an individual circuit emulation service. So, and in T1s, you're doing a structure agnostic TDM over packet, or SATOP, as you might hear. Again, hope you love those acronyms. And then circuit emulation.
Always love an acronym with a small letter in it too.
Right. And then you can also move just a full STS1, right? That's another type of cross connect you can build. So if you have an STS1 that's coming in from a carrier and you need to drop it off as a DS3 or an STS1 on another OCX wherever, you can just map across that entire STS1 as well. But again, these are all individual services that you'd build. So you'd have a tunnel that each of them would go over. So you'd be able to have that active standby functionality in your network and give you that 50 millisecond failover. But the cool thing about that, again, is to use your whole IP MPLS network as a distributed digital cross connector, DAX, for those circuits. So rather than having to, plug that OC48 that you get from your larger carrier into your old Titan 5500, and then, send it out different DS3s or OC3s, you can just bypass all of that infrastructure and use your IP MPLS network as your DAX.
Yeah, and you can get the same or better quality of service. You can get the same protection schemes. Maybe not 4-fiber BLSR, but
well, sure.
Nobody really used that anyway.
Yeah, exactly.
Yeah, and the key there is you're converging it with the rest of your network. So you're not, like you said, you're not building a separate network just to run this. What really, in the grand scheme of things now, is a small amount of traffic.
Yeah, and you're not utilizing a lot of bandwidth with which to do it either, right? A DS1 is still a megabit and a half. Let's just say we're very conservative and we add a 33% overhead factor on it for the headers that it takes to do it. You're still talking 2 megabits.
Two. Yeah.
Yeah. 2 megabits for a single DS1 across your, at this point, 100 gig or maybe even 400 gig backbone. It's a drop in the bucket.
Yep. And this also sets you up for, really the end goal is at some point all these things are going to need to be transitioned over to newer services. Now some are going to be a challenge. I know there are there are services within utilities that are T1 based. There are building alarm systems that are T1 based. There are things out there that probably it's going to be very difficult to change, but over time, everything needs to evolve and needs to improve. And this really sets you up for that, because really IP networks, MPLS networks seem to have the most flexibility and the most capability to carry any kind of traffic and deliver it where it needs to go.
Yeah, the longevity seems quite good on this type of network. And the way that this kind of sets you up is that, if you have to put a small device in your customer's endpoint to provide that IP to TDM conversion, then you still have a fiber that goes in there, and you have a device that's sitting there. And the ribbon devices we use to provide this, they don't just provide TDM interfaces, they provide Ethernet interfaces. So the migration path is essentially built in.
Yeah, I think that's a key also, right? Is that we've got these devices that do both, and they do both in parallel. I think not all the solutions do that, especially things like OTN. OTN just does OTN. So, building, like I said, building for the future is the key to this. And I think this is a really solid solution to move some of these more traditional customers in that direction.
Sure. And the best part is when you get down to like that site that just has the single DS1, we can even do that just on a pluggable, right? It's just an SFP. So you can deploy, whatever your Ethernet endpoint you want there, and you just pop in this SFP to do the T1. And when they want to change to an Ethernet service, you just pop in a different SFP, and you've got 1 gig or 10 gig Ethernet ready to go.
What's funny is they probably have both there right now anyway.
In a lot of cases.
Yeah. So you put the right box there, you collect all of it up into one and send it away as IP traffic.
Yep.
But anyway, any other thoughts that you have on this?
I think that's a good, 101 on what is circuit emulation and how does the TDM to IP migration look like. I mean, I think TDM is going to have a fairly long tail. I don't think that this is a 3-year solution. I think this is probably, it's total guesswork here, because 10 years ago I would have said it's 10 years, but I still think it's 10 years. It's kind of that there's always just going to be somebody who hasn't quite switched yet.
Well, yeah, I think as long as there's still the ability to create the gear, then we're going to be able to run these circuits. But
yep,
over time, people are going to stop making the parts. That's going to be the real indicator of when we're done.
But hey, we see a market for this, right? We are the guys who are building new TDM interfaces for our routers.
Absolutely. And like you said, some of them are just pluggables. So those are going to be around for a while. We've got new interface cards for some of our routers that allow us to do these things at pretty high density.
Mm-hmm.
So in the situations where you have that, we've got that capability, and yeah, it becomes new gear.
So hopefully you've learned everything you've ever wanted to know about circuit emulation, at least that you can pack into 15 minutes or so of babbling between two nerds.
Exactly. Thank you for your attention. If you're still watching this long into the into the podcast, and if you have questions or you have suggestions or comments, please leave them in the appropriate section down below in whatever podcast tool this ends up in, and we'll do our best to respond and work those things in. And especially if you have suggestions for new ideas, things that you'd like us to talk about, please put those in there.
Yep. As the kids say, like, share, and subscribe. Smash that like button.
Exactly.
Yeah, we love some topics to again mildly entertain you with.
And always remember, be careful what you ask for.
That's right.